How'd it go? What'd you do? Panicked? Number 3, table Y. Jack, how you doing? Want to help me with one of these?
Let's see. See.
Which one have you looked at so far?
I've just been sort of looking at B. I don't know.
Looking at B? You're like, addition, it's my jam, go for it. What'd you do? Did you go h of x plus g of x and then evaluate at 10?
Kind of.
Kind of. You did something different.
No, not really.
What'd you do?
I finished it. I just finished it.
You looked at it, you wrote it down. Is that, so far that's what we got?
Yeah, pretty much. Just been thinking.
Just thinking right now. Okay. My suggestion maybe is to write something down. Did anybody go, alright, h plus g of x. I can do that. I feel like they're not sound. There we go. H plus g of x is h of x plus g of x. So that's 3x plus 3 plus negative 4x plus 1. And then you're like, oh, okay, I got negative x plus 4. That's what h plus g of x is. So h plus g of 10, oops, not x, 10, is negative 10 plus 4. Did you get negative 6? Did you do it differently?
Yeah. So I did it where I looked at h and it was 3x plus 3, so I multiplied the 3x. So I plugged in 10 for x.
Nice.
So I got 30 plus 3, which is 33.
33?
And I went to the other one and I did that, and I plugged in 10 for x, and I got negative 40 plus 1, which is negative 39. And then I added those two together, and I got negative 6.
Awesome. Yeah, thanks. So that's 2 ways you could do that. You could evaluate, you could rewrite the expression, simplify it, add those two together, and then evaluate at 10, or evaluate one, evaluate the other, and add them together. Nice, you got the same thing. Hopefully that makes sense that we got the same thing. How about another one? Number 3, radical table. Mindy?
Oh.
Taking over for number 3. I know you're radical 4, which maybe would be 2. Now I'm confused. Anyway. Yeah, which one are you looking at? C. Ooh, I like this. Did you simplify those?
I just multiplied G and H together.
You did multiply G, you did n squared plus 4 plus 2n, and you multiplied that times negative 3 times n plus 2?
Oh, yeah.
Awesome.
I got, should I simplify it or tell you what to do?
Whatever you did.
Okay, so I got negative 3n cubed minus 12n minus 6n squared plus 2n squared plus 8 plus 4n.
Oh my goodness.
But I might have done it wrong.
Like that?
Yeah. And then that simplified down to negative 3n cubed minus 4n squared minus 8n plus 8. And then
Okay.
I inputted so you just do negative 3 minus 4 minus 8 plus 8, which equals like negative 15 plus 8, which is negative 7.
-7. Anybody else get -7? No.
Oh.
Okay. Did you do it Anderson's way? Plug in, find g of 1?
Yep.
Would be 1 plus 4 plus 2, which is 7. And then you found h of 1, which would be -3 times 1 plus 2, which would be -1. 7 times -1.
Yep, that's what I did.
I don't know if one of those is easier than the other. I appreciate the different methods. Any others? Alright, you feeling good on A, Jay?
Yeah,
What'd you do there?
so I just multiplied, let's see, it was g of 3 minus h of 3, and so I just, changed all of the x's to 3,
Uh-huh.
and so I did g of x equals 2, parentheses 3 minus 5, and then 4 of x plus 5 was 4 parentheses 3 plus 5, which means it's 6 minus 5 is 1, and then 12 plus 5 is 17, and then 1 minus 17 is negative 16.
Anybody else get -16? Alright, now for the hard one, maybe? Division. Ugh. Divided by g of x, remember, is f of x divided by g of x. And we get 3x minus 1 divided by x squared minus x. Did you get that? Nice. Done. Did you try to do something after that? Don't. You could write this a little bit differently, but really it's not going to get any simpler than that. So, I guess you could. Yeah, never. Not really. Not really. That's about as good as it gets for division. A lot of times there's nothing you can do. Do you have your Chromebooks? Do you have that document? You can look at the T problem. Is what I really wanted to look at today. And other things. How we doing on time? Doing okay? Ooh, yeah. I think we ended class on this one, division problem. G divided by f of x. Sorry, yeah, g divided by f of x. Which is going to be 4x plus 8 divided by 2x minus 12. I think I said at the end of class that is as good as it gets. You can divide everything by 2, so you have a common factor of 2 on the numerator and denominator. So you could write 2x plus 4 divided by x minus 6. But that is as simple as it gets. I think people get tempted to like divide parts of the fraction. Careful, don't do that. Uh-oh, no internet? Does, you have like the Google Doc you could access anywhere? No? Uh-oh. Oh, goody. will you look at the T problem? I guess make sure, maybe double check that. You can rewrite H, dividing everything by 2. Will you check with your neighbor? Oh, forgot about Jill's savings account. And I just noticed I got the wrong date on the Canvas page. I believe today is the 8th. Alright. How'd it go? Thanks for closing things that aren't looking at what I'm looking at. Where are we at? What'd you get? What's going on here? Jill? Savings account? Number 1. Table life. You know who you are, person taking over for number 1 eye. What's going on with R of X?
I got R of X equals 350 plus 55X.
350 plus 55X. What do y'all think? Dax, sound good?
Yeah.
What do you like about the equation?
That you have your principal and then you have your rate of change.
Nice. Starting with 350, saves 55 bucks each month. All right. How about number 1, table E? You know who you are. Scarlett, what do you think about T of X? What would that be? Her Tor savings account.
Would it be R T of X equals 25 plus 40X?
25 to start out plus 40X. Avery, what do you like about this equation?
It looks like the first one that has what you start with and then what you're going to gain.
Alright. Alright. How much does Annie have all together after X months of touring? C of X. Rain, what do you think?
C of X is 375 plus 95X.
Nice. 375 plus 95X. Jeremiah? Anything you would change? Anything you like about C of X, this equation? Does it look good to you? Her total amount of money she has in both savings accounts? Does that sound right to you? Should we have 375 here as like a starting value?
350.
Okay, yeah, we got 350 in the one account, right? What happened with the other one?
She put 25 into start.
25 to start that one. So does that make sense that we'd have 375 to start out with? All together? And then we're making 95 a month? Oh, nice. Alright. What's R plus T of 3? Jay.
T of 3 is $660.
R plus T of 3 is $660.
Yeah.
Did you forget your dollar sign? Mads, what are you thinking for R plus T of 6?
$945.
$945. Pretty good gig here. R plus T of 10, going on tour, 10 months. That's a school year. Coming back with how much, Grant?
Let's see, I got 1,325.
Not too bad. Did you forget your dollar sign? Alright, the T problem, of course, notorious. This was a level 4 problem on its skill check, and it caused a lot of problems. So I thought, it'd be good to, talk it through. Got some tea. What do you do with tea? It's too hot. You put it in the freezer. You also measure the temperature of it when you pour in the, yes, okay. You have a thermometer with your tea. I know how this goes. Life is a big experiment, right? Okay, so Jack made some tea. Am I right? Was this, when was this, last night? 2 nights ago? What kind of tea was it, Jack? The good kind?
Yeah.
Alright. The chamomile maybe, nice and relaxing. Alright, it was too hot, put it in the freezer. The freezer is at 0 degrees Celsius. Not sure if that's important. That's when stuff freezes. Can be modeled by an exponential decay function. Least number at your table. Say something about an exponential decay function. What's it going to look like? It goes down. I like that. By how much? Okay. Not hearing everybody saying things. What was said at your table, Scarlett?
It will be decreasing.
It would be decreasing. Okay, what was said at your table, Mads? Ooh, I like the hand. Okay, wait, like this?
Decreasing at an increasing rate.
Decreasing at an increasing rate, okay. What about, Carson, you're going like this? Or which one is it? It's going down, or is it that?
I think it's at a
Decreasing rate?
Yeah, it would be that.
Okay. Yeah, I'm not giving you much here. Like I said, level 4 problem. Anything said at your table, Sophie?
Yeah, since it's an exponential function, it's either going to be multiplied by a decimal or divided by something.
Awesome. Yeah, I think we could think about dividing by something or multiplying by a fraction or decimal. Nice. Yeah. In order to fit the formula, a times b to the power of x, I like to think of it as multiplying by a fraction or decimal. It's really can work though by dividing. Nicely done. Okay. So 60 degrees Celsius maybe doesn't sound like much. That is hot. Burn your tongue. Am I right, Jack? 1 minute goes by, 54 degrees. Okay, we're getting a little bit better. Maybe you can touch it. I don't know. Write a function t of x that represents the temperature after x minutes. I think this is the hardest thing. Check with your neighbor. Greatest number at your table. Make sure everybody's got a function. What functions do you have? Awesome. 9 of 29.
For the T, I got
0.9.
60 minus 6x plus 4.
Okay. Here's the function I've seen the most around the room. What do you think? 60 times 0.9 or 9/10. Same thing, right? To the power of x. Does that fit the formula that we were kind of talking about? That there's a fraction or decimal that's less than 10 as our multiplier, as our common ratio. Does this work? 60 is our initial value. Is that going to give us an exponential decay function? What would this look like on a graph? You'd start at 60 on the y-axis when x is 0. we're at 60, and then when x is 1, 54, and then what?
48.6.
What is it?
48.6.
48.6. Okay, what's it gonna get close to, but never reach? 0. Does that kind of make sense in this situation? At some point, it seems like it would reach 0.
Trees after big.
Yeah. Or would it?
No, it would. I'm serious, it would.
You're pretty sure it would, yeah. So maybe this function isn't accurate for all values of x. Although, at some point, I would say we're close enough to 0 that maybe, 0.00001 degrees, is that gonna freeze? Probably. Although, at some, will it ever get lower than 0? Probably not, if the freezer temperature is 0, right? Okay, nice job. Yeah, this is exponential decay. Okay, room temperature is constant and can be modeled by the function r of x equals 20. Jack made some more tea. This time he's like, let's just let it sit out in the room. The temperature of the tea in the room can roughly be modeled by the function t of x plus 4 plus r of x. Oh dear, getting weird with it. So, I just said graph the function. I'd like you to write it out as well. And then insert an image of your graph. And, like what are some key features of the graph? So, anyway, let's think about what this function would be. T of x plus 4 plus r of x. What would that look like? What's t of x? Do we have that? Maggie, what do you got for t of x?
Like 60 times 0.9.
Nice. Okay, so that's t of x. 60 times 0.9 to the power of my input x. Okay, but my input is not x. What is my input? X plus 4. My input is the exponent, so we need the x plus 4 in the exponent. Okay? Plus r of x. What's r of x? Plus r of x, which is 20. Alright, so this is it. You have a way to... So I thought about making this graph like by hand. That's how the skill check was. But maybe you could go to desmos.com/calculator, and that will bring up a graphing calculator online that you could use to look at the graph and see what's going on with it. Probably could have put a link in the document there, huh? Just wanted to leave it up to you. If you wanted to do it by hand, that's fine too. Oh yeah, that's pretty cool. I would definitely like you to understand what we just did to get that function. So that's kind of cool that Desmos actually does let you type in the functions and then type it exactly um, how it's shown there. So I got t of x and r of x, and you can just say t of x plus 4. That's pretty cool. Yeah, I don't know. Does this make sense? What do you think? So the red line for me is, so you could take a screenshot and insert it into your document if you have like a good view. Maybe you want to zoom in. I mean, for me right now, I think it's helpful to look at all three of the functions. Like the red line is the temperature of the tea in the freezer. Green line is the room temperature. And the blue line is that like put together. Anything you notice, Grant?
Well, one thing I noticed is that once you do combine the functions, instead of the blue line almost hitting 0, it almost hits 20.
Awesome. Does that make sense in this scenario? Okay, maybe once again, it seems like it actually should hit 20, where we know it's not, it would just approach 20. But once again, we're going to get so close that, I mean, maybe those molecules are moving just a little bit faster, 0.000001 degree warmer. We definitely wouldn't notice that. It would say like, yep, it's 20 degrees. Nice. That would be something to mention if you write something like that, what Grant said. I think that's really helpful. Anything else you notice, Ryan?
Hold on just a sec.
Just that it levels off at 20, or approaches 20, I should say. Awesome. Yeah. I mean, maybe we could think about why that is. Okay, as I increase x, I'm going to make this, we're multiplying by 0.9 more times, right? 60 times 0.9 times 0.9 times 0.9 times 0.9. So it's going to get smaller and smaller, but then we're adding 20. So if you look at the red function, the best we can do is get really close to 0. If I add 20, that means I'm going to get closer to 20. Because I'm going to get closer and closer to 0, and then plus 20. Anything else, Gabe?
I think with this graph, it's just showing you that whatever the outside temperature is, that's what the tea will get closer to.
Nice.
So like for the freezer, it's going to get closer to 0 degrees Celsius. If you just leave it on the counter, it'll get closer to room temperature.
Sweet. Yeah, love that. Yeah, so if the room temperature were higher, it would approach that. What about the steepness of the lines? Like, is the red line steeper than the blue line? Like, kind of weird, Maggie. What do you?
Yeah. Well, for me, it kind of looks like the combined one like decreases slow or faster.
It kind of looks like it decreases. The blue line decreases slower.
Yeah.
Right. Like, I'm not just adding 20. Like, look at when x is 20. What are we at? It's like 7.5, something like that. 20 plus 7.5, it seems like it'd be up here, right? It's a little bit lower. It's like at 25. So that's because I've got this x plus 4. So I might not say that it's decreasing at any slower or faster rate, although for the same x values, it is decreasing slower. Does that make, do you think that fits this scenario? Do you think it would do you think it would lose temperature faster in the freezer than in the temperature, or than in the room temperature room? Yeah, I think so. Took me a while to like put together for the skill check. Because it's not just a matter of adding 20 to get it the same yes, adding 20 will change the asymptote, but to kind of model the situation like Anderson, what do you notice about like the y-intercepts?
I noticed that it seems on the y-intercept, they all cross at the same place, it seems like. I don't know if it actually is, but.
Yeah, it turns out they don't actually
Yeah,
both
it looks
cross
like
at 60, but I tried my best to get it close to 60 so that it would kind of fit the situation where Jack is warming the tea up to 60 degrees. Alright. Hopefully you've said some things that we've talked about. First thing, the temperature that they're approaching is different, right? We see that it's approaching 20 degrees, which is the room temperature, which makes sense. Maybe it'd be worth noting that they both start at 60 degrees Celsius, and maybe they are decreasing at different rates for given x values, for given intervals. We could even talk about like average rate of change. And that, I think that would show us what's going on. Like, I mean, maybe we could look at from 0 to 20, what's going on there. The red function goes from 60 down to 7.5. What's that decrease? What temperature change is that? What's the average rate of change over 20 minutes? We would do 60 minus 7.5. I don't know if these are actual values. Sure looks like it. Divided by 0 minus 20. So I'm getting like 52.5 divided by negative 20. I would expect a negative rate of change because it's decreasing from there, right? I don't know. 5.25 over 2, negative. Something like negative 5 over 2. What about the blue line? That's going from 60 to 25 over 0 minus 20. What are we getting here? Like 35 over negative 20? So something like 3.5, negative, again, negative 3.5 over 2. Probably could, I mean, you can kind of see the difference there. This one's decreasing 3.5 degrees every 2 minutes. This one's decreasing 5.25 every 2 minutes. Probably look at those as different ratios. Alright. Rain, anything you'd like to share? Just watching some movies? Oh, the Google drawing. Cool. On how to do a Google drawing. Okay. Right on. Okay. Once you got something written, will you read it to your neighbor, and will you open the new document that I wanted to spend way more time on today, but that's what tomorrow's for. Right now, I was debating, skill check either Wednesday or Thursday. Probably Thursday. Before you close this document and submit it, will you read what you wrote, or what you noticed to a neighbor, starting with the greatest number at your table?
For the function, instead of using 0 and using 20, I then reduce it and pass the 20 because the 20 is not being used. The red function is constant and has no rate of change.
Anything else we could add to it? about like the rate of change, anything about like the intercepts,
Yeah.
something like that.
Looking weird.
Yay.
Fingerpressing analytics is 60
Okay.
Celsius at the beginning. At the beginning, 0 minutes, and then desktop control temperature to lower each 20 degrees Celsius, approximately room temperature. And at 7 minutes, 3 T's will reach 100, will reach 0 degrees after 111 minutes.
On our activity, adding, combining functions, I hoped you saw, and most people saw, like how can we combine functions? You could add them, you could subtract them, you multiply them, divide them, yeah, those operations that we know and love. That you can do on numbers, you can do on functions, sure. I mean, just like whatever the outputs are, just add them together and you get a new function, cool. You could model the temperature of T by adding an exponential decay function with a constant function. Right, Dylan? At the end, if you did get all the way through the combining functions activity, there was what we call composing functions. So this is another way to combine functions. There we go. So I found a cool function machine diagram showing what's going on here. Composition of functions, or composite functions, refers to combining functions in such a way that the output of one function becomes the input of another function. You with me so far? You can see G and F, beautiful. The range or y values become the domain or x values of the other function. So that might get a little confusing, but so here's an example. I've got this sphere. Put it in, if I think of that as x, whatever. I put it into the g function, out comes a cube. What would the cube represent here? What's my output? If I put x into my g function. Y, yeah. Or g of x. Yeah? Exactly, yeah. It gives me my y value. We might call it g of x. G of x is my output. Okay, now I'm putting the cube, drops into the f box, the f function, and out comes the faceted ball thingy. Kinda wish that was different, but you know, whatever, it's cool. So normally, if I put something into the f box, the f function, what comes out? F of x, right? But what did we put into f of x? G of x, yeah? So we use different colors here, here we go. G of x. So this function put together, this new function that we make by putting these functions together, by making the output of one the input of the other, we call f of g of x. Okay. Now, remember with like adding functions, we said things like f plus g of x. So kind of to do the same, to have the same idea here, like we might talk about f plus g, the new function f plus g. Well here, if I want f composed with g, we write f, and it's a circle, not to be confused with multiplying. It's an open circle. You can, it's like an operation you can find in your Google Doc. And we would say f of g of x, or f composed with g of x. Okay? You can write it either way. Both of these mean the same thing. These are equivalent. I would prefer to write it like this, with f parentheses, g parentheses, x parentheses, parentheses. Because it reminds me to do inner parentheses first and work out. So I feel like this is easier to understand. I do the g function first. So this new function, I would put in x, or the sphere, and out would come the faceted ball, right? The f plus g of x would be my output here. Okay, maybe another example would help. Today I just want to introduce this to you. This is kind of like taking notes, I guess. So, for example, f of g of x, f composed with g of x. If g of x is 2 to the power of x, and f of x is x plus 1, f composed with g of x, which one am I doing first? I would write it like this, f of g of x. Which one am I doing first? G of x. So let's say my domain, so for 2 to the power of x, my domain would be negative infinity to infinity. Let's just look at these values. If I restricted my domain to these values, what would my output be? Let's see, 2 to the negative 2 power? 1/4, nice. 2 to the negative first? 1/2. 2 to the 0? Better not say 0. 2 to the first? 2 to the second? 4. Boom. Okay. Now, and what's the range here? What's the possible y values? Can I get 0? No. You can't get 0. You can get really close to it, right? Anything up to 0, but not including it. Okay. So now these become my output for my new function f, which is x plus 1. So my domain here would be 0 to infinity if I'm looking at all possible inputs. And just as an example, we're looking at these: 1/4, 1/2, 1, 2, 4. Okay, what would my output be here? F of x equals x plus 1. I'm just going to add 1 to each value. 1 plus 1/2, 3/2, or 1.5. 1 plus 1 is 2. 2 plus 1 is 3. 4 plus 1 is 5, and so on. What would the range of this new composite function be? Yeah, 1 to infinity, right? Not including 1, there's no way we could get 1, right? So, kind of looking at those functions combined, I think I wrote this, f of g of x, oh dear, would be 2 to the power of x plus 1. Alright, we will look into this tomorrow and probably the next day, Wednesday, and then skill check Thursday. Thank you for your good work with the T problem. Tricky one. Yay! Awesome, yeah.
Thank you.
Thank you.